65% of the world's cowpea production comes from Africa. This commodity is not just grown on over 12.8 million hectares of land in sub-Saharan Africa, but consumed by over 200 million Africans.
Nigeria is the largest producer of cowpea in the world, but we are also the largest consumer. And unfortunately, we may also be the largest importer. This is the unfortunate scenario that we have. Presently, the average yield is less than a ton, maybe about 700 to 800 kilograms per hectare. But potentially, we could get up to 2 tons or above.
Our national demand is about 7 million in terms of production, but we are producing slightly above 3 million, about 3.8 or so. So we have a deficit of more than 3 million to meet the national demand. In terms of coffee production, we are the leading producers at the moment. But the major producing states are those that are attacked by insurgency. So the production has dropped due to insurgency in the major producing bean states. But now, our farmers since last year have started going to farm because of the level of degradation of the insurgents. Our beans farmers have started mobilizing back to farm for production.
The grain itself is a leguminous crop, that has protein content in it, about I think 23% protein or so, or thereabouts, and then it also has some little carbohydrate. It's also an energy food. It's body building. It's a source of protein to the body. It's a source of minerals, and so on and so forth. Essential amino acids are contained there. Some few essential amino acids that the body cannot synthesize. So it's actually very useful to children under the age of 1 to 5. So it prevents malnutrition.
Agricultural scientists describe the cowpea as the most important food grain legume in the dry savannas of tropical Africa. Cowpea is highly rich in quality protein and serves as a good source of quality fodder for livestock. It provides cash income for farmers as well.
A balanced meal must have protein in it, and the easiest and cheapest that you can get is from cowpea. Before now, our people always thought they could afford meat. And people always thought that protein is from meat, or poultry, large ruminants and things like that would always be affordable. But now the situation is different. Most people cannot even afford meat, as it were. So the substitute is in cowpea and things like that. So the focus is becoming very obviously that of getting very cheap means of getting protein. And there is nothing better qualified than cowpea.
In those rural areas where they cannot afford animal protein, they can't afford egg, they can't afford meat, most of the families. So it's beans. They actually resort to beans. The soup, every soup, contains beans. And then we have other delicacies, Nigerian delicacies that are made from beans. We have moi moi, that's Accra. We have kose in the north. And kose is eaten by almost every household. It's either kose or moi moi. We enjoy it. It's very rich in protein.
There is, however, a major challenge to cowpea cultivation in African nations like Nigeria. It is the pod borer, scientifically known as the Maruca vitrata. The pod borer is a major lepidopteran pest which inflicts severe damage to cowpea crops.
Maruca, I think, is the most important, is the most devastating of all the insect pests. Maruca, you can easily get 100% yield loss. Easily. It ranges from 60, even a weak infestation, you'll get maybe about 50% loss. So if it's moderate to high, you get 100%. And the unfortunate thing is, it will come when the thing is podding, So you have done a lot of other agronomy activity, you have wasted a lot of money, and then what you are looking for is gone. So Maruka, next to Maruka is Port Sucking-Bug, but Maruka is I think is number one.
Maruka is one of the most important, or I would say the most important pest of cowpea, wherever cowpea is grown, especially in Nigeria. This pest could cause from 80 to 100% yield loss. Maruka is a very versatile pest. It's highly polyphagous insect pest. What I mean by polyphagous is that it can eat wide variety of plant parts and different variety of crops. So it attacks the flowers, the pedicule, the leaves, and the pods. So you could see how economical the pest could be. So it's a very devastating pest on cowpea. It will cause 80 to 100% yield loss.
Farmers go through a lot to produce these beans, and one of the major challenges they have is insects that eat up the beans in the farm. There's this insect called pod borer. They usually attack the flowers, and once they attack eat the flowers are bought. And you know, if the flower does not develop, the pod cannot develop, and you cannot have your grain or your seed. You know, so this is a major problem that farmers go through.
In really bad cowpea infestations, farmers could lose majority of their yields. 70 to 80% of yields could indeed be lost to the Maruca vitrata in a farming season.
The local varieties, the Maruca attack them. Instead of me to spray less 2-3 times, I used to spray almost 4-5 times. And most especially the 48, IR 48, the variety released by the Institute for Agricultural Research Station. I used to farm it for more than 20 years now, but I suffered a lot. I sprayed almost 10 times before I can get something reasonable for my customers. Customers used to come to visit me to buy from home. I don't take my produce to the market for long, but I've been suffering in the hands of the Maruca, most especially on the local varieties.
Adversely. You know, maybe if you take, let's say, if a variety can produce 3 tons, let's say, per hectare, and you have Maruca making it impossible for them to get even maybe 2 bags, maybe that is 200 kg, then you know it is very devastating. So it is like that with Maruca, and this is the major problem in production. You see, when a farmer plants, especially, you know, because it's seasonal and the whole crop or a large percentage of it is destroyed, the tendency is the farmer will not go for that crop the following year. So whatever, you know, he is able to salvage from the damage is what is available. And then, you know, our farmers almost live from hand to mouth. So anybody who just does that and suffers this loss will be devastated. So they look for other crops that are able to withstand some of the effects of either the climate or insects or whatever.
This challenge made the African Agricultural Technology Foundation, AATF, alongside public-private partnerships to introduce a pod borer-resistant cowpea project that will boost cowpea production in Nigeria and other countries in sub-Saharan Africa.
We have been developing the pod borer-resistant cowpea since 2009 in Nigeria, and we've achieved tremendous success. And right now, we have been able to gather all the scientific evidence and data to show that this technology is working. With this technology that has been developed, farmers will no longer be, the insects will no longer be able to eat up the flowers and the pods, you know, of the beans. So what you plant is what you get. So you can imagine sometimes farmers lose up to 80, up to 90% of their yield, and they resort to spraying several times. So right now the spraying is going to reduce significantly, thereby saving cost for the farmers. If you also consider the drudgery that the farmers go through in doing this spraying, the drudgery will also reduce, and then the yield will increase. Not that the gene itself increases yield, but because it addresses a constraint, which is the insect attack. Now the yield is going to increase bountifully, and ultimately the essence is that the farmers can produce more and generate more income through the sales, and the consumers will have more to eat and also get them more cheaper.
Several confined field trials have been held in sites across the country.
This project, we started the project in 2009 in this field you are seeing. Initially, for the first 3 years, 2009, 2010, 2011, we planted in those areas where you see those iron frame. That is the area we planted this GM crop, 5 lines there. We tested those lines for 5 years under netting in that place you are seeing. So after we have finished testing them in the netting, we decided to go multi-locations. We added some fields in Zamfara State and Minjibur Kano State, and those plus that of Zaria.
Confined field trials for testing the efficacy of the Bacillus thuringiensis gene, also called the BT gene, in controlling the maruca through the BT cowpea has been successfully conducted in Nigeria by the Institute for Agricultural Research of the Ahmadu Bello University in Zaria.
We integrate the genes into the farmer's preferred variety, and those materials were also identified which are having kind of resistance to these spot-borne insects. And the identified lines, they were now also sent to multi-location trials in 3 locations. That's Zaria, Bakura in Zamfara State, and then Minjibur in Kano State. Those performed also excellently. And we also give those materials now to farmers to test it on their own to see how they are performing. From our own side, the materials were excellent because we realized about 4-fold yield increase, meaning that about 4 times higher in terms of yield compared to the conventional one. So having seen that one from our side, the scientists part, we now give it to farmers to test it. So they tested for almost 2 years, and we are now in the 3rd year of their testing. So this year, we are now trying to compare, to see the kind of level of damage that may be recorded from the conventional materials.
At the confined field trial site, the BT cowpea is planted just beside the conventional cowpea. This trial, for example, shows the BT cowpea has successfully resisted the maruca, with the insect unable to attack the bean spores, but the conventional varieties planted here have been badly attacked by the maruca.
Conventional cowpea, we observe that this maruca, they seriously like it. You can see the maruca on almost every plant in the conventional cowpea. So we take data on that. Coming to non-conventional, which is the transgenic, if you look at it, throughout the 3 years we have been doing work on them in the multi-locations, we find out that the maruca does not affect the PBR cowpea. We do the intensive data collection on it. I'm telling you, you hardly see damage of maruca on it.
The BT cowpea is also ready for harvest, while the conventional variety, which was planted at the same time with the BT cowpea, is not ready to be plucked.
I've participated in the BP cowpea trial, and I find it that it's very, very good. We have benefited a lot from it because it's early maturing compared to our local variety which we have been farming before. it's early coming, early maturing, and it doesn't. In terms of spraying, we have a few spraying schedule. We have been, in the time past, we used to spray almost 6 to 7, 8 times, but this time around, we spray almost 3 to 4, and we get what we want.
Many local cowpea farmers have been part of the confined field trials. They say the trials have shown that the maruca can indeed be controlled by the BT gene. This means they won't have to spray so much chemicals which are harmful to their health and also affects profits. To these farmers, the BT cowpea is a wonder crop which can end the setbacks associated with farming cowpea.
The BT cowpea variety and the conventional one were planted sideways at the same time. They both received 2 sprays each, but the conventional was badly attacked by the maruca, while the BT variety was not attacked. The BT variety is also ready for harvest with many full pods, while the conventional one is not ready for harvest with many of its pods already damaged, which means low yield.
Nigeria's maruca-resistant cowpea project has been hugely satisfying. Scientists are positive it could help resource-poor farmers boost food production and enhance ecological security in Africa.
This BT is the next solution, and if we have BT cowpea, if we promote it on a good genetic background, so that is we get a cowpea variety that has resistance to a lot of these diseases and is resistant to striga, then you bring the BT in it, you have a super cowpea. So it means instead of spraying 5 to 6, 7 times, you may need to spray only once. So once there is resistant to all of these and you're resistant to maruca, then you are thinking of pot-sucking bug. So you will have cut down spraying significantly, which is more environmental friendly than spraying 5 times. So BT, to me, is more environmental friendly than the spray. So this is the technology we should go for.
The confined field trials for the maruca-resistant cowpea have been held in Nigeria since 2009. Approvals for its commercial release are now being awaited. The BT cowpea variety is expected to benefit African farmers who rely on cowpea for food, animal feed, and income. This will in turn have a multiplier effect on the country's food production, wealth creation, and overall economic stability.